Can you be in two places at once? In our world ruled by classical mechanics, this would seem impossible. But there is another world, the quantum world, where our preconceived rules don't hold up, and there's one fundamental principle responsible for this madness. So what is quantum superposition? And what does it have to do with that cat? Let's start with a little experiment. I have a filter with two slits in it, a detector screen, and a beam of donut holes. When I send a blast of my solid donut holes towards the filter, those that make it through will travel straight towards our donut detector and form a pattern of two spots, just as we expect. Now let's scale it down and send a beam of light at it. Instead of seeing two patches again, we see this. When our light wave passed through our filter, it split into two waves which then interfered with each other. Where peak met trough, they canceled, and where peak met peak, they added together to create these alternating bright and dark spots, an interference pattern. But what happens in the quantum realm when we shrink down to the subatomic level? When scientists fired electrons at the two slits, their seemingly random landing spots began to build up one at a time to look exactly like an interference pattern.
Let's see an instant replay.
Even though we're detecting our electrons on the screen at single points like our donuts, they seem to be traveling like waves and interfering with themselves. So are elementary particles donut waves? This idea of something exhibiting both wave and particle-like behavior is key in quantum mechanics. Everything has a wave nature. Even light was both a particle and a wave. Quantum waves act like any other, but they aren't actual disturbances in matter. Rather, they're mathematical waves that characterize quantum particles by describing the probabilities of the object existing in a given state or having a certain property. Hear me out. Let's say I'm in my room with a list of tasks I have to complete, and I roll a pair of dice to determine what to do first. You, an observer outside of my room, have no idea what number I rolled and thus what task I'm doing. But you do know the probability distribution of all the possible sums, and that, for example, there's a roughly 14% chance that I'm doing task number 8 right now. Since we can only measure the chances for an outcome to appear at random, we can't draw any conclusions with 100% certainty. And so our object must exist in all its possible outcomes at the same time. And we say it's in a quantum superposition. We never see a superposition. You're not opening my door and seeing 30 Saniyas everywhere. And that's because the act of observing causes our wave function to collapse into a single detected state. That's why our electron only hits in one spot, why opening my door reveals only one me, and why that cat everyone talks about is awake or asleep only after we finally peeked inside the box. But we can see the consequences of superpositions, and that's why we got that interference pattern, since the wave function could split and interfere before it hit the screen. Observing our electron earlier would collapse its superposition, and it would act just like a particle instead. As mind-boggling as it is, this is a fundamental principle of our reality. It explains how electrons can coexist in orbitals to form chemical bonds. It's the basis for quantum computing that will revolutionize research. And without it, these donut holes couldn't exist. And that's the true gift of the quantum world.